All right, here we go.
Everything you say seems to have
that quality issues are recording from their headquarters. I don't know whose responsibility that is. Alright, are we recording?
Yep.
Cool, thank you. Alright, so welcome back everyone. Just a bit of, I guess, housekeeping or whatever. So in case you guys didn't see, I posted on the Learn board that I'll be taking tomorrow's lecture as well. I have some carpet layers coming in because I'm doing renovations at home, and Thursday was the only day they could do, so I will be doing Tuesday, Wednesday this week, and Christopher will be doing Thursday, but everything will be back from that. The other thing is, in case you haven't seen, I put the first assignment, the MHIT603, on the website. We'll go through these lectures and then maybe at the mid lecture break, we can have a look at the assignment. Alright, cool. So we've got two kind of shorter topics now, paper prototyping and low fidelity prototyping. So we might try and get through both of them today, or see how far we can get anyway. So we can move on to software prototyping tomorrow, which is, I don't know, more interesting to me, but maybe not to other people, but then I'm a programmer, so of course it would be. Alright, so we talked last week about, I guess we sort of started looking at what is prototyping. We looked at user need analysis, so how can we get requirements. We looked at some tools and techniques which we can use for prototyping. And over the next two topics, we're sort of just going to look at some various prototyping methods, starting with paper prototyping. Now for all the, well, I was going to say for all the engineers, but really for anyone who's not super excited in software, I do apologize because a lot of these examples aren't sort of software related, but hopefully you can extrapolate. And I did try and throw some new examples in there which aren't so software sort of heavy as well. So when we talk about paper prototyping, again, this is all pretty, obvious stuff really, but it's really more to give you guys a sort of perhaps some extra ideas for stuff that you can do around this, these sort of topics. So paper prototyping, we're talking about basically not necessarily just interfaces, but sketching ideas effectively. So experiences, ideas, anything that you've got, putting it down on paper, using paper as a means to very quickly sort of flesh out these ideas for the various reasons we discussed, empathy, testing, exploration, brainstorming, inspiration, all that sort of stuff. So when we talk about paper prototyping, we're specifically just talking about using things that you find around the office, which is great because we have a lot of that stuff here, and if we don't have what you're looking for, you can ask and we'll probably get it for you. So it all comes down to what we were talking about last week. They're easy to criticize and quick to change. So we don't want to build these really heavy-duty prototypes, and I do have a video in the second topic, which sort of shows some really cool prototypes, but when you sort of think about them logistically, how much time they would have spent to make them, they're probably going to be a bit more defensive around, this is the way we're going, rather than be prepared to change them. Another good thing about paper prototyping is it's a very creative process, particularly for teams or groups. Anyone can pick up a pen or a pencil and draw on paper. You don't need to be an expert, you don't need to learn how to use 3D printing software, Photoshop, anything like that. Even if your artistic ability is limited to drawing stick figures and basic shapes like squares and triangles, you can still help illustrate an idea and get an idea across. You can use it for usability testing, focusing on the flow of interaction rather than visuals. So we'll talk a little bit about two sort of offshoots of paper prototyping called wireframes and screen flows later, which are very specifically sort of looking on the flow of interaction. So how do people interact with our design? But we specifically use various sort of notations, I guess, and vocabulary in our drawings to deliberately sort of try and reduce the amount of visual work. So I sort of mentioned this earlier, the concept of in a wireframe, if you are drawing something which has an image in it, you just put a box with an X in it, because we're trying to get away from that whole focusing on how pretty it is. Really, we want to focus on how good the experience is. And use a lot to test out concepts before the real design begins. So you'll notice all these slides carry on the first page low fidelity prototyping. That's because we're still at the very low fidelity part. The idea is we're trying to flesh out ideas before we actually start really building anything which is going to have any sort of substance in it, which is sort of what the rest of the course from after either today or sometime tomorrow we'll get into. So here's one sort of example of how of prototyping, and this sort of follows along from what I was telling you guys about that PhD student who was doing her research on sort of education or educational games for environmentalism. So you can see here somebody has whipped up a bunch of sort of UI designs, UI designs and various sort of modal dialogue boxes which can pop up to help you sort of, I guess, explore the interaction somebody has with your system before building it. So I do apologise, the picture's a bit hard to read on the screen, but it looks from here, we have the from line contains people, the subject line contains specific words, etc. It looks like this is probably creating rules for email. So if you want to automatically sort of split up your email so that all emails from Christoph go into your important folder and all emails from me go to your I'll deal with this one, I can be bothered folder. You can set up these email groups. So we have the sort of one box in the background which shows the main dialogue, but then there's a whole bunch of other pieces of paper that they're sticking over the dialogue boxes, and they're allowing people to just touch on them to mimic the interaction they have of actually using the system. And then somebody's obviously sitting there in the background, like swapping out pieces of paper. So Hazel, who was a PhD student, did something very similar to this for her very initial stages of her PhD. She basically had a screen printed out and various interface items, and she would give you various scenarios or scenarios to run through it, or tasks to complete, and she would ask you to, basically touch on things as if you were clicking on them with your mouse. And the good thing about that is that before creating any of the user interface in code or whatever, or even on a computer, she could very quickly test out to see how people do stuff. I think from her findings, from speaking to her, she found a lot of stuff that she thought was quite intuitive. Turns out other people didn't find intuitive. So she would say, complete this task, and she had an icon which was supposed to be like a task book, but it was just a book effectively. And a lot of people overlooked that because they didn't know if that was like a save button or something. The user interface metaphor she was using were unclear. So by sort of seeing how people interacted with it, she could see what was working, what wasn't working. She could also see, if there were things that other people had thought, or other ideas people had about how an interface should work that she had perhaps missed. So, for example, she had a little mini map in the corner which was just supposed to show your position in this virtual world. And that was really all it was supposed to be used for, but she found a lot of people were now trying to, should say, now go to your next thing, and the idea was you're supposed to use your keyboard and mouse to move around. A lot of people were clicking on the map and just saying, oh, well, I click here, and then I click on the place where I need to go, and it would take me there automatically. And so because she was doing that, she was able to find these things out, and because she was effectively acting as a computer in kind of a mini Wizard of Oz study, she was also able to react to unpredictable inputs like that. Like if you built a system and you didn't anticipate that people would click on the map and say, take me here, your system just wouldn't do it, and people would go, oh, okay, that's, I can't do that, I'll find another way. Whereas because she was sitting there acting as if somebody tapped on that, she could sort of ask them what they were doing or try and intuit what they were doing and then react accordingly. So if somebody would tap on it, she'd be like, oh, why did you tap on that? And they'd be like, oh, I want to bring up a map so I can choose where to go. And she's like, okay, imagine a map pops in front of you and where would you go? And then for the next person, she could make sure she had a map printed out as an object, as an option. So very quickly she was able to sort of really, I guess, expand her understanding of how people are likely to interact with this interface that she created. So here's an example up top, and here's another one down the bottom for various widgets for some sort of, looks like a paint program. So you've got zoom and pen and flood fill and eraser and move. And they don't have to be at all pretty or complicated. They're really just there so you can explore things like placement, you can explore things like user interactions, user flow. Here's another really cool example which came out of one of the interaction design books. And this was for, I believe anyway, a company which was setting up a VRML website. So for those of you who don't remember VRML, it was a very sort of failed web technology for basically doing 3D graphics on the web. The VR was supposed to be virtual reality, but it didn't, as far as I'm aware, it didn't actually connect to any virtual reality stuff. So it was really like web graphics, so like WebGL or HTML5 or whatever. So this is 93, I think, so going from a while back. But the idea is the same. So they, in this thing, they had a 3D model of a Porsche by the looks of it, and they wanted people to be able to interact with this Porsche. So think back to, well, for those of you who are old enough to think back to 93, you know, computers were still fairly novel for a lot of people, and particularly doing things beyond interacting with 2D interfaces was fairly novel. So to have this 3D car that you can click and move around and stuff was a pretty new idea. So to figure out what sort of interactions they wanted to do, they basically whipped up this very basic website, sorry, not even website, this program where people, they displayed these images, they said, here's what the user interface will look like, and then they asked people to use their mouse to show how they would change. Now, there was a few people, I don't know that they explained this very well, or people didn't necessarily understand it, but the idea is this is what you see on the screen, and this is what you're trying to achieve. So at the moment the car's side on, but you want to be able to rotate the car so there's a 45-degree rotation to the right. So instead of seeing the car side on, you want to be able to rotate the car so it's that way, and then on the side it is rotate the car 45 degrees that way and then 20 degrees down, so rotate it up and to the right. And what they did is they basically had people use a mouse to supposed to show on this image how they would basically cause that interaction to happen. And anytime it's a click, it shows a red dot, and anytime it's a drag, it shows as a green line. And you can see what happens. So a lot of people, by far and away, the majority of people grab the front of the card and they pull it to where they want it to be. You can see there are a few outliers in here, so some people grabbed the corner of the image, other people clicked on the side of the car, imagining that maybe there was some sort of button there which would rotate the car around. But generally speaking, with this particular interface, most people's natural reaction was to grab the front of the car, or click on the front of the car and rotate it around. For both the rotating just in one axis and rotating two axes, people and one sort of pulled it to the left, and then the other they sort of pulled it down to the left. So then they thought, okay, well, what if we can try and, there's a few people you can see who clicked on the edges. What if we sort of try and support them, and particularly more so here as well, what if we try and support these people by adding buttons that they can click around the outside? So now they've got some buttons around the outside that you can click, and you can see now there's a lot more people clicking. So a lot of people click on left. For some reason, a lot of people clicked on right. Some people clicked on the bottom arrows. Someone clicked on the wrong image. But there seems to actually, in trying to support these people, there's actually less consensus now. So they've actually tried to make the user interface better, but really, I would argue that this is making it worse, because now, at the very least, we've got like a large number of people clicking on this arrow, but a large number of people clicking on that arrow as well, which there's no way I can think of where those two arrows could do the same thing. Theoretically, they would do the exact opposite thing. So arguably, this is actually a worse design. And again, this has all been done by mocking up two images and just asking people to click and drag on stuff. And likewise, we see the same thing on up and right. There's no real consensus around, how this should be done. So then they had attempt 3. They're like, well, let's, this is obviously confusing that people are unsure as to, a lot of the people who clicked on the front of the car are now clicking on that arrow in front of the car, whereas the people who clicked behind the car are now clicking on that arrow. So we've effectively got two opposing arrows, which people are treating as if they do the same thing. what if we move the arrows so they're not on the thing anymore? That way, if people want to click up here, they can click up here, or if people want to click on the arrows, they can click on the arrows. And once again, we can see there's not a huge amount of consensus reached. So it does, I would say it's probably slightly better than this, where you've got sort of about 50-50 people clicking on the left and right arrows. Here, it does look like more people clicking on the left arrow. A bunch of people still trying to click and drag on the screen, which, that's fine. We can support 2 different modes of interaction if we want. But there are still people clicking on these other arrows, which, is probably not, it's not like it's something which is going to seriously negatively affect them. They'll click on it and they'll realise it doesn't do what they think it does, and so they'll do the other. But if we can avoid people making mistakes in the first place, that's always better. So from these 3 different illustrations and diagrams, I would argue that the most basic plain interface is probably still the best one. There is the largest consensus in people's actions in this one, whereas when you start giving people more options, they start getting confused about what those various options do. I think you'd have very different results if you went on to run the same experiment these days, because through touch screens, phones, and tablets and stuff, people are very familiar with swiping and rotating 3D objects. So it would be interesting to run this experiment again, but I would say you would see a very strong consensus into the sort of behavior of clicking and dragging. But even that is kind of an interesting thing. This was done in '93, back when touch screens were sort of not even really something that people thought about, but the fact is the results sort of it ended up that was the sort of natural behavior of people anyway. So even before that was sort of the done thing, that's sort of how people tended to interact with 3D content on a 2D display. Right, so paper prototypes. They're very quick and dirty. You don't need any software. So you can see in some of those examples, we basically prototyped whole interactions without needing any software. And they're very inclusive, so anyone can do them regardless of abilities or any other categories. The cons, they lack context and scale. So when we talk about context, we're talking about the context of where the task would be performed. So if you are, developing a interface for something which runs on a phone and you have it placed out on the desk, it's a very different experience doing that than it is when you're actually on a phone. Perhaps you're developing something that people can use when they're commuting or something. All these various conditions. So there's a good example actually coming up. I can't remember if it's in this set of slides, the next one. But talking about text-to-speech and stuff like that. So it's not a paper prototype as such, but the whole concept of text-to-speech or text input is fine if you're in a private room, but it's a whole other matter if you're in a public space. So by not having it in the context that you're operating at, you have to be aware that people behave differently. If they're in a nice, quiet, private room with a lot of space to work in, than if they're in public or if they're on the job site or whatever. Paper prototypes, depending on how they are developed, can be hard to share, particularly if you're talking about co-located. So we have a really awesome brainstorming session here and end up with thousands of pieces of paper, but we want to collaborate with another research lab. That can be quite difficult because even if we scan all the pages, they've lost a lot of the sort of context and the conversation around what we've developed. We look at it because we were all here and we're part of it, and we're like, oh yeah, that's right. And this person had that idea, and then that led to this idea. But if you just sort of provide someone with all the paper, unless you have a separate documentation step, it's really just a bunch of pictures that don't sort of have a lot of context between them all. So just as a quick diversion, or I guess to perhaps work around one of those, or possibly a couple of those issues, is paper prototyping with hardware as well. So paper prototyping with hardware is effectively paper prototyping, but taking it out of the nice, clean desk lab experience and actually putting it into the context that people are working in. And it allows you to experiment with tangible aspects of your solution. So if you're designing user interfaces or you're designing a new physical product, it allows you to look at things like how big is it, and we've got a nice example coming up, sort of talking about that in a minute, for things like does it fit in your pocket? I feel like mobile phones have sort of actually gone the opposite direction to that. I remember in the 2000s it was all about how small your phone could get. And if anyone's seen the movie Zoolander, you know, they almost mock that when they're running around with cell phones, which are literally that big. Whereas these days, my phone, particularly with its case on, I can barely actually fit that into most pants pockets these days. And that's not even that's just an iPhone 6. It's not a 6S or anything, which is even bigger. But back in the day, it was quite important that things fitted into your pocket. Things like how heavy is it? Is using it going to cause fatigue? So if you're creating a physical product and it's super duper heavy, so if you think back to Gunther and his, what was it, 17-pound projector, you know, that's quite a lot of weight to be lugging around 8 kilos plus his laptop plus everything else. And, you know, it might come with the case like if we think back to Gunther and his projector that had a built-in tape player in it. These days, obviously, that seems kind of ridiculous. And I guess back then the question is, you know, is the tape player really something he needs, or has technology reached a point where everything can be done digitally on a computer? I guess the most recent example of that is Apple and a lot of other companies' choice to remove the headphone jack from phones. So their argument for doing that was because the headphone jack is really large, so by far away the largest, thickest component in a phone is now the headphone jack, and it also takes up a lot of space for effectively what is two connections. So Apple's argument was, well, if we get rid of that and put bigger batteries in it, we can make phones thinner, and technology has reached the point where we can use Bluetooth headphones, no worries. A lot of people disagree with that, and it's become this massive point of contention. I guess time will tell as to whether they made the right decision taking the headphone jack out. But you know, this is something that I'm sure they probably spent a lot of time prototyping and looking at before they made that call. And they're confident that it was the right decision. And the fact that a lot of companies mocked them for it, and then a year later released their new phones, which none of them had headphone jacks, says that perhaps there's something to it. And then other things as well. Can you use it one-handed when walking? You know, the old stylus tablets can't really be used one-handed, and that may be an issue if you're producing something which you expect people to be able to use on the go. If they have to sit down in order to focus on it and use it. That's why I guess touchscreens have come the way they have. I remember the big thing where Steve Jobs said that you will never see an Apple device with a stylus, and then the iPad Pro came out with a stylus, and there was a lot of contention about whether that was the right idea or not, because what he claimed was never going to happen. Then his successor came along and did, and a lot of people were like, oh, you know, you've lost the dream of what Steve Jobs did. And I'm not defending in any way, shape, or form any of these people's decisions. I have nothing in that fight. I just used whatever product is best for the time, personally. So the fact that I use a Mac and an iPhone is not because I'm an fanboy, it's because we do mobile development. And on a Mac, you can develop for iOS and Android. On a Windows PC, you can only do Android. So unfortunately, this was best tool for the job. Anyway, after that digression, so here are some examples. So I think this was a company, I think they were called Ansel or something like that. We're looking at developing digital cameras back in the time where digital cameras were large and clunky and everything. And they wanted to test out various form factors and stuff like that. So they started with just a box in the rough shape and had people carry that around to get an idea. And the good thing about this is obviously you can weight it as well to sort of simulate the experience, and you can sort of see, is this rough form factor an appropriate size, is it an appropriate weight? They have little pieces of paper or perhaps stickers here that they could use to design various user interfaces. And then once they were sort of, you know, they found what they felt they could find out from that, they moved on to slightly more advanced, what are these, wood or cardboard blocks or something in the shape of the camera, that then they could sort of see, take that to the next level and sort of explore, you know, how does this affect the usage of it. So here is a real world example which is a lot of text, I do apologise, but a very good real-world example of sort of paper prototyping with hardware. And this is from the days of when Palm Pilots were things. So Palm Pilots were little PDA, personal data assistants that you carry around with them, basically like a cell phone which can make phone calls. Yeah. So Hawkins, 40, Palm's chief technologist and pilots creator, designed one of the first handheld computers, the GridPad, a decade ago. It was an engineering marvel, but a market failure because he says it was still too big. Determined not to make the same mistake twice, he had a ready answer when his colleagues asked him how small their new device should be. Let's try the shirt pocket. Retreating to his garage, he cut a block of wood to fit his shirt pocket. Then he carried it around for months, pretending it was a computer. Was he free for lunch on Wednesday? Hawkins would haul out the block and tap on it as if he was checking his schedule. If he needed a phone number, he would pretend to look it up on the wood. Occasionally, he would try out different design faces and various button configurations using paper printouts glued to the block. So, you know, you'd probably see this guy and think he was absolutely insane, but it's actually a really interesting sort of experiment in that it's one thing to create something and test it for 5 minutes, but he was doing this for months, you know, months and months of carrying this thing around, trying to make sure he pulled it out as often as possible to see, did he eventually reach that point where he's like, it's just not worth it, you know, it's too much work to pull this thing out and pretend like I'm doing it. It's just easy to carry a notepad or a piece of paper in a pocket that I can write down stuff on. So while we talk about, you know, having these quick and easy prototypes, and I feel like for a big part of it was fairly quick and easy, it was paper glued to a piece of wood. He really took the testing to the next level, and he really immersed himself in this experience of having this device just to make sure that the one thing that his last product, the GridPad, failed for was not going to happen again. It wasn't going to be cumbersome and troubling to use. All right, so as a sort of related, kind of tangential topic, there's an app called pt1, which is a neat little app which allows you to do prototyping on a device. But it, again, does it in a really simple and intuitive way. So I'll look up the YouTube videos so you have a look. So I don't know if there's actually any voiceover. So the idea behind pt1 is it combines paper prototyping with prototyping on the device. So just like you would do with normal prototyping, you just draw out all your screens and your pages and whatnot, and then you go through and you take photographs of them. And then using the very simple tools, you can create basic interactivity, so you can link various bits and pieces together. So when you tap on stuff, you know, it takes you to various screens and stuff. So again, you're basically creating this mobile app, but all you're doing is drawing stuff and then using a couple of very basic sort of linking tools to create these apps together. But again, it allows us to do a bunch of things. So pt1 from memory you can share, so you can create your pt1 and then you can share it with people. So it gets over that issue we had of paper prototyping is hard to share because you can share it digitally. It gets around the lacking context and scale, because if particularly, you know, obviously pt1's only really useful if you're looking at apps, but it allows you to experience the design of the prototype in the context that it's designed for, so you can actually use it on your mobile phone rather than just having some sheets on the table. And arguably, it sort of gets around the documentation a little bit, and that people can play with it and explore it and learn about how it works for themselves. So a neat little free app I recommend download it, or at least it used to be free as far as I'm aware it still is. Download it, have a little play with it, and obviously there's a million other competitors and stuff out there now that do things differently, so by all means have a look at some of those as well. All right, does anyone have any questions at this point?
Create real apps?
Not so much real apps, no. So we'll look at some other examples soon which allow you to create or get closer to the process of creating apps. Ultimately, at the end of the day, it sort of depends on what functionality you want. So if you're expecting to create really sort of interactive applications which are more than just user interface stuff, eventually you're going to have to get your hands dirty with a bit of programming or using a more evolved tool. But some of these tools can actually export to various user design elements and parts that you can actually use in these other apps. So some of them that we'll look at later on, you can actually build an experience and then export that, and then you can actually write some of the back-end code which does other stuff as well. All right, so we'll move on to wireframes and screen flows. So wireframes are a sort of, I guess, subset of paper prototyping where we're looking at sort of functionality and layout without getting too bogged down in the visuals of things. So we're looking at things like how navigation works, intended functionality, how the interface elements work together, but we're deliberately excluding things like typographic style, color, and graphics. Typically, you can add those things in, but again, that's something that you will add later on. You don't want to get bogged down with those things early. We're really just trying to sort of shape things, move stuff around, just trying to figure out how things fit together. We're looking at how the experience hangs together and leaving room for design to be created. So this is an example wireframe which is made by a tool that we'll look at in a minute called Balsamic. And Balsamic has the typical sort of wireframe sort of visual vocabulary, I guess. So things like having boxes with an X through them instead of images. If you look at it, they've deliberately done stuff to make it look a little bit rougher than it actually is. So they have squiggly lines, they have sort of cartoony font, all that sort of stuff to encourage people to look at it not as any sort of finished product, but rather just to sort of look at it as this is a work in progress. So yeah, wireframes are created for the purpose of arranging elements to best accomplish a particular purpose and depict the layout or arrangement of the content, so things like interface elements, navigational systems. This is the same text from the last slide. Okay, but yeah, in other words, it focuses on what a screen does, not what it looks like. So for this example here, we can see this is perhaps a profile of someone on a website or something. So we have the name, some address details, maybe a photo of them, it's just with the lorem ipsum default text, a little bit about them, maybe a video of, if it's a research page, a video of their research, some other images and some galleries or whatever. So despite the fact there's actually no content here which actually tells us anything, we can sort of look at this and get an idea of, this is potentially what it's going to be used for, how it can be useful to us. Here are some other example wireframes. So on the left is a website. There's a website, I don't know, maybe 10 years ago called Smile City, which was briefly popular. And I have a feeling this is sort of something along that line where it's an all-in-one thing where you can go and do online shopping and do online surveys that you get paid for. And you have your profile and it's social networking. One of those sort of conglomerate websites which did a whole bunch of things really poorly. And the only reason it was really popular was because it was new and there was nothing else like it at the time. I don't even know whether it's still around anymore, but yeah, this is the sort of thing that you might expect for it. So you have this web, so these are 4 different views, as we can tell. There's some buttons at the top. This is button 1, 2, 3, and 4. And it looks like one's sort of like a Facebook newsfeed with some profile and other information. The second one is something about redeeming points. So you collect points, obviously, because you've got your name and points in there, and some things you can redeem your points on, maybe for online shopping or air points or whatever. Then you have a message board by the looks of it, because it says message board there, with various notes you can pin on the wall, and then an account summary page, so something about earning points, other actions, surveys, account summary. But very simple design, but it gives us a real sort of really high overview of how this whole thing sort of hangs together. So we can look at this and sort of figure out how this website would work or this interface would work, even despite the fact that it's very basic. It's got a bunch of boxes with X's in them. So they obviously don't have to be websites. They can be mobile. They can be any sort of interactive thing. So not even within the software realm. If you have something where there's interactions which go between various things, wireframes can be used to sort of illustrate that. Struggling to think of an example, but if anyone else has anything pop into mind, let me know. So there are various tools as well which can do it. So Balsamiq is the one we looked at, we mentioned already. So Balsamiq allows you to create and test UI wireframes quickly. And it deliberately means that you can't focus on fonts, alignment, colors, you just click and drag. So there's going to be a few YouTube videos showing some of these things.
It takes a team of people working together to be successful, but the roles involved communicate in very different ways. Not having a common language results in problems we've all seen, designs that can't be built, applications that are hard to use, or products that just don't meet customer needs. It's like everybody on the team is imagining a different product. Stop imagining and start seeing with Balsamiq Mockups. Balsamiq Mockups is a rapid wireframing tool that helps you get the right product together. It was designed to get business people, developers, and designers on the same page before coding starts. Let me show you around by building an application you may be familiar with. I'll start by grabbing a window control and giving it a name. I'll resize it and customize it a bit. Balsamiq Mockups 3 has over 75 built-in controls for all kinds of user interfaces. Next, I'll add an image placeholder for the album art. Now I'll add some text. Notice how it snaps into place at preset distances from other objects. Controls also automatically align when positioned close to other controls. In addition to specific UI controls, there are also some generic ones, like this geometric shape control.
So fast forward
With over 500 items that I've prepared in advance.
the links are all in the lecture slides if you want to go together.
Balsamiq Mockups 3 also allows you to create
Video
website just like
towards the end. So, you know, so this is obviously a real-time video, but I'm impatient. So in a minute 30, he's created what is given the name Spotify, is obviously supposed to be a Spotify client. So yeah, you can really quickly mock up how things are potentially supposed to look. So there are some things in there like having images and stuff, which is typically not what you do in wireframing, but you know, allows some flexibility in there. But yeah, it's super quick and allows people to have sort of these discussions. And obviously being that it is actually in the digital realm, it can be shared with other people. And you can export, add some interactivity and stuff as well. So it again gets around some of those limitations of purely sort of paper prototyping. There's some other ones as well. So UXPin is a similar product. However, I guess the reason we mentioned UXPin separately from Balsamiq, obviously because there's millions of these things out there, I'm not going to go through all of them, is that UXPin is a little bit more flexible around, so you can import from Photoshop and stuff if that's your expertise. But you can go through and you can choose various sort of libraries of stuff. So if you want to do things like use various interaction metaphors or whatever, or elements from iPhones or social sharing or whatever, they have various libraries that you can pull stuff out of to make it look a little bit more, a little bit more like that. Has typical sort of user interface. We talk about them later on. Transition, sorry. So things like having accordion. So the accordion transition is if you go to a news site and it has like headlines and you can click on it and it folds out to get more information. That's what's known as the accordion transition or the accordion template. And there's a whole bunch of other ones that you typically see on websites. And the idea behind these templates is that, or patterns, is they've fallen out of years and thousands of projects of people trying to do similar, different projects but different or similar tasks. And so these templates or patterns are ways that have been commonly found to be easily understandable. And the idea is if everyone uses the same patterns, then I can go to one website which uses a pattern and a different website which uses a pattern. And I can immediately understand how both websites work because they use the same template. even though perhaps they look different or they work slightly differently, it's still the same interaction metaphor. So this has a lot of those sorts of various bits and pieces in it. It works with a bunch of different form factors. So here's them building a website in it. You can do stuff with Google Glass. So if you're interested in Google Glass and stuff like that, there is various libraries which allow you to design for Google Glass. So obviously there's limitations around Google Glass around how small the screen size is and the fact that it's not an opaque background and everything. And yeah, you can add some basic interactivity as well with some of those patterns and those templates that we have. And then you can share and comment on other people's, comment on things within the team as well. So you can get around sharing, you can have the documentation sort of implicitly in it, and you can download and test out the prototypes as well. Azure is another one, so this one I believe was originally out of Microsoft maybe, and was sort of one of the first and, well not one of the first, one of the early ones which was sort of quite popular. I think Christoph at least maybe used to use it in his course, so I'm just going to mention it here. I'm not going to go into any more detail on that because assuming that he still is, you'll learn a lot more about it with a case study there. But the point is that there's lots of these different tools out there. I'm not going to say which ones are good and which ones are bad because really that depends on what you're trying to do. But those are three of the more popular ones. Balsamic in particular, you'll see come up over and over again as being something that's super easy to use, super fast, and has a lot of the functionality for more traditional wireframing. Things like UXPin tend to go a little bit beyond traditional wireframing, and some people would argue it's not a wireframing tool for that reason because it allows you to focus a lot more on the visual aspects. But you know, it's context, and I'm not going to argue for or against that. Yeah, wireframes are good for defining content, good for documenting screens. Depending on what sort of wireframing tool, it does have some cons. So sometimes they're bad at showing interactivity and flow. Things like UXPin does have a lot of that built into it, so it's not such an issue. Can't really use them for testing. Again, depends on what tool you use. For things like UXPin, though, arguably it's slow. You spend too much time describing. Things like Balsamic would be arguably better if you're looking to do things quickly because it forces you to not focus on things like images and texts and fonts and colors. It deliberately forces you just to put things together as an idea. So the various tools, I guess the pros and cons are almost on a per tool level rather than on the concept of wireframes because all the different tools handle things slightly differently. So we'll just move into screen flows as well because I'm almost loath to put this as a separate topic because it sort of follows on quite nicely from wireframes, but certain people argue that they're very different. But the idea behind screen flows is we're trying to, if we think about wireframes as sort of being more static, so we're looking at more layout, screen flows are more about the experience. So we're not just focusing on a single screen or a single interface at once, we're focusing on how it all fits together. So we're looking at steps, what steps are required to complete a task, how we have to complete the task on a click-by-click or interaction-by-interaction level, rather than just here's screen 1 and then here's screen 2. It's like how we get from screen 1 to screen 2. We'll preview the experience, see how everything flows together. So if we think about these two things, this is from the Xero accounting software. A wireframe, or this is probably even too in-depth for a wireframe, but you can imagine these could be two wireframes. But what screen flows are really concerned with is this bit in the middle. How do we get from this screen here to this screen here? What has happened? What has changed? What steps were taken? So it's a sequence of user-driven software processes that are presented as a series of graphical user interfaces. So if wireframes are concerned with how these two steps look, the screen flow is concerned with everything that happens in the middle of it. So here's a quite in-depth screen flow showing this theoretical video recording program called Bollywood Capture. So, Bollywood is India's Hollywood, where they pump out hundreds of thousands of movies every year. Often, not to quite as high a production standard, but it's more about telling a story and everything. It's the idea of behind Bollywood Captures allows people to create these films on their mobile devices so it's more than just having your camera recording function. It actually allows you to sort of put together a whole movie from a series of clips. And you can see here, this is quite an in-depth thing showing how various buttons work. So you can see there's various buttons down here and they're labeled with numbers, where if you click on it, it will take you to that screen. So if we click on this, it will take us to screen 11. If we click on this one down here, it's, I can't even read it, screen 31 or whatever. Or if we basically continue recording, we go through various other options. So this one is obviously quite in depth, but it gives you an idea of how various interface elements hang together and the interaction that they provide as well. Unfortunately, it's kind of too low resolution to read, but it gives you an idea of what a screen flow might show. So really, as I mentioned before, the screen flow is looking for the whole experience, not just the individual states that we find with wireframes. So I mentioned patterns, and so patterns originally, I don't know, they originally came from software, but they're very prominent in software. So in software we have these things called design patterns, which is when you're encountered with a problem, chances are someone else has probably already had that problem before, and here's a way of fixing it. So we have things like the singleton pattern, we have the observer view manipulator pattern, we have various patterns for dealing with sorting and data flow and all this sort of stuff. And the idea is that if you come across a problem, you can look up various patterns and find a pattern which you can use to solve your problem. And because it's been tried and tested by hundreds of thousands of developers before you, you know it's going to work, you know it's going to have these advantages and these disadvantages, and it saves you from having to basically invent something new yourself. So this idea was extended to user interfaces for user interface design patterns. And this is a website which, if we're just talking about designing user interfaces, designing screen flows, has some very common design patterns for user interface that we can use to sort of solve problems for ourselves. So for example, getting input. If we are creating something which requires users to create a password, and we want to indicate to them how we can show to them how good their password is, we have the password strength meter design pattern. So we have, for each design pattern, we have a problem summary. You want to make sure your user passwords are sufficiently strong in order to prevent malicious attacks. It has an example showing how that works, and then it has some information about usage and some additional examples. And then it has a whole bunch of information about the design pattern itself. So if you look at this, you should say, oh yeah, that's familiar, I've seen stuff like that on a lot of websites. And that there's a reason for that. It's now commonly known design pattern, or user interface design pattern. And by all these websites using these same design patterns, we can ensure that users can immediately understand them without having to go, oh, what's this showing? How does this work? And we are free, so the idea behind patterns is that they're free to use. They're not patented, you don't have to license them or anything like that. They've been basically contributed by the community as ways to resolve common problems. So some of the other examples, having navigation tabs, so tabs across the top of a website that allow people to very quickly navigate to large categories, and gives a clear indication of the current location as well. So that could be tabs across the top, that could be breadcrumbs, so it shows you how far down the chain you are. All these things are there and available for us to use. So these design patterns can be used to sort of very quickly mock up various screen flows and stuff rather than recreating it. You can just say, and here we're using this design pattern. All right, so for an example of a tool which I have a feeling calls themselves, okay, so it doesn't, I was going to say, call themselves a wireframing app. They don't need to say they're app dev. Effectively, this is a nice app which follows on from what we sort of saw in Pop App, but it really focuses on transitions and the interaction and the user experience over just designing screens. It's called ProtoWire.
Creating a visual simulation of a mobile app before you jump into production is a must. Prototyping will help you build your app faster and cheaper and with much less risk. The process, however, is often time-consuming and frustrating, and it doesn't represent the real thing. Not anymore. Proto.io is a silly fast way to create fully interactive mobile app prototypes. You can create realistic, shareable prototypes that work as your app should. And Proto.io does more than just linking screenshots. Just select the device you want to build a prototype for and start dragging UI components to create visually stunning interfaces in no time at all. Designed specifically for mobile, Proto.io can emulate everything an app can do. Interactive touch gestures, screen transitions, animations, and even orientation changes. All without a line of code. And hey, with Proto.io, not only can you preview and share your prototype on the desktop, but you can experience your prototype on the actual device. So, whether you're a UX guru, designer, coder, or you just had a great app idea, Proto.io is the best place to start. Sign up now for a 15-day trial and get silly fast prototyping to go.
So yeah, that's Proto.io, which is, obviously they talk about themselves that they're concerned more with transitions and recreating that, or creating that user experience rather than just linking screenshots together, which I would argue is a bit of a subtle dig at Pop App and stuff like that. But that's fine. They're different tools for different purposes. Yeah, so again, something to have a little play with if things like mobile development is something that you're interested in. And just to finish up, quite nicely, finish up paper prototyping. So screen flows are an effective communication tool. They're easy to evaluate because they not only look at interface, but they're also experience as well. So we can give them to real users and have them try stuff out. They're good for explaining changes over time, so we can see how the experience will evolve as we use it. Easy to share depending on what you're using. There's obvious focuses and limits because you can interact with it. If something isn't implemented, it becomes obvious because it doesn't do anything. Reduces documentation, supports low high fidelity, no coding necessary. So obviously this is a large list of pros. I'll leave you to come up with your own cons, but again, these are all tools, as all the videos talk about, they're tools to use before you start developing. And really that's what these first few lectures are about. All the things that you can be doing before you start actually building something to make sure that when you start building it, you know what you're building, you're as productive as possible. You've hopefully worked out a lot of the main or major problems and roadblocks so that you don't hit them further down the line when something becomes a lot more difficult and expensive to solve. Any questions? No? All right, cool. So we'll take maybe a 5-minute break there, and when we come back, we'll look at some non-paper prototyping and non-software examples as well for how prototyping can be used for various things, and we'll talk a little bit about the assignment.